Hey everyone. A couple of days ago, I posted a picture of my Steam Deck ELT reader on Reddit, and there was some interest from the community as to how I got that up and running and how you're able to read an ELT with computer software and SDRs rather than with the older VAVI test equipment that most avionics shops have. So I figured I'd do a short video kind of instructing how that's all done, talking about the hardware you might need, the software you might need, and demonstrating the operation of software ELT readers. So what I've done is I've just gotten a base stock Windows 10 install on a VirtualBox. I decided that a VirtualBox would be the easiest to do it with because it's a clean install. Everything's very straightforward and there's nothing changed. No drivers are installed or anything yet. This is just right from bone stock. I've also decided to do it on Windows because it's a little bit easier to figure out than Linux was. The Steam Deck is running a version of Ubuntu. It's running Ubuntu 22.04 for my purposes, but it took quite a bit of figuring out along the way for a lot of the steps. And most people have a Windows PC available to them, so I figured I'd sort of start with a Windows tutorial. I've also got a little rundown of some of the things that are good to know to start doing this with. So I'll start by talking about hardware that you'll need for this. So the first thing that is basically the whole way you're able to do an ELT read is with something called an SDR, which stands for Software Defined Radio. Typically, conventional radios use physical components, so oscillators and gates and things like that in order to receive and decode essentially radio waves. What an SDR does is an SDR is able to do all that a conventional radio can do using a chip or using software essentially installed on one large active component or multiple ICs and things like that. Benefits of SDRs, they have a much wider range than conventional radios. They're solid state, so they're a lot smaller and they require a lot less power. So typically speaking, you can run SDRs off of USB. So the SDR units that I would recommend, especially for ELT reading, is the RTL-SDR. They're the most common SDRs out there. They're pretty cheap. I'm going to quote everything in Canadian prices, but usually RTL-SDRs for just the unit itself are around $50. And then, it goes up to about 70 or 80 if you buy the pack with some antennas and things like that with it. But pretty cheap. You can get them on Amazon or a lot of the times from the manufacturer's website. The ones that I typically use for ELT reads are receive only RTL-SDRs. And the naming scheme is a little bit confusing. The RTL-SDR was created by RTL blog. They make the RTL-SDR V3 and now the V4. They vary in the chip that they use. And then the NOOELEC, which is, I guess you could call it a rip-off brand, right? Even though the RTL-SDR is open source, they essentially copied RTL blog. The NOOELEC is up to the version 5, which has the same chip as the version 3 RTL-SDR. And that's the most common chip, the one that's in the NOOELEC V5 and the RTL-SDR V3. It doesn't really matter for our purposes, but that'll come into effect a little bit later regarding one of the pieces of software that I'll talk about. The RTL-SDR version 4 does almost exactly the same as the version 3, and subsequently the NOOELEC version 5. But the version 4 has a built-in down converter, so it widens the frequency spectrum a little bit, and you can get down into those HF and sometimes even medium frequency bands. A couple of other devices I want to talk about really quick. The Hack RF and the Blade RF. The RTL-SDRs are receive only, whereas the Hack RF is a half duplex receiver transmitter, so transceiver, or a SDR device. I use the Hack RF myself. I have a unit from the company's not coming to me right now, but I have a version of the Hack RF for things like VOR station emulation. So you can emulate a VOR station and inject that essentially into a nav radio. I also have it for things like VHF comm, transmission, and reception. Because of it's half duplex, it can only do one at a time. The Blade RF is sort of my next iteration once I save up a little bit of change. The Blade RF is 2-channel, full duplex, and it has a much higher top end frequency spectrum. So it can do things like GPS and stuff like that a little bit easier than the Hack RF, which is a cheaper alternative. In terms of antennas, I usually use the antennas that are bundled with the RTL-SDR version 3 that I have, or the NOOELEC version 5. I usually just use the whip antenna, the cheap little metal retractable antenna, and you can essentially tune the length of that in order to better receive whatever frequencies you want to receive. And since you're not doing a huge long range read, typically when you're checking an ELT, it doesn't really matter. You can also direct couple to the ELT, but I would put an attenuator in there first so you don't blow out your circuitry. In terms of computer hardware to run the softwares that you might need, it's really quite basic stuff. I had this all running on a Toughbook, an older Toughbook, a CF53 from 2014, I think. And it has like an Intel i5 dual core, 2.4 gigahertz if I remember right, 16 gigs of RAM. I think this virtual machine, I've tuned it to have dual core. It's obvious it's running off of my 7800 X3D, so the cores will be a bit beefier. But I have it tuned to dual core, and then I have 8 gigabytes of RAM on the virtual machine. So you really don't need a lot. The big thing you do need is a sound card. You can use a sound card built into your motherboard, or you can have an external or internal sound card. But why you need a sound card is that's essentially what's doing your analog to digital conversion, your ADC. So typically sound cards go from digital to analog. You would drive a sound card as a DAC, obviously to turn the digital audio signals, right, into actual sound waves that come out of your speaker. But the people who've coded the ELT decode program have found a way to essentially run that backwards. And they inject the received waves, the received propagations from the ELT that your SDR picks up, and they translate that into digital, which is then further translated into all the digits and things you need to read when you're looking at an ELT. In terms of peripherals, I threw this in here just because, it's good to have a mouse and keyboard if you're driving this off of a mini PC or a desktop, obviously. Good to have speakers, all the stuff you should need for your regular PC setup. Software. So here's where we'll kind of start doing things on the virtual machine. There's a few different categories of software that we'll go through installing, and I'll also talk about quickly. The driver's utility. So the RTL-SDR and any NOOELEC, anything built off of the SDR, this SDR chip in particular, needs something called Zadig in order to install its drivers. It's not a plug-and-play device, so you need to sort of hold its hand through driver installation in order to get the SDR to communicate with the OS. It's very straightforward, and the website for any of these SDRs to purchase them will have information on how you can do this with Zadig, but we'll go through it here as well. And then if you're running this off of Ubuntu or any sort of a Linux distribution, you'll need to download some libraries, some .libs for the RTL-SDR or any SDR you're running. Another thing that I like to use as sort of a preference is virtual audio cables. Because you're using the sound card to translate analog to digital, what you're going to end up doing is injecting that analog signal into your sound card. And if you're just using your sound card as a medium, the audio will come out of your speakers as well. So just to be a bit less disruptive, I like to avoid spouting the actual ELT frequency out of my speakers. So I typically get a free virtual audio cable program to route the audio straight from the RTL-SDR software into the decode software, so I don't have to listen to the blips. Speaking of SDR software, there's a wide range of SDR softwares that you can use. With the RTL-SDR, most of them work just fine. I like to use SDR Angel for a few reasons. First of all, the control is very, very good. It gives you a lot of parameters you can change and adjust. There's a lot of different demodulators that you can attach to SDR Angel. So you can do things like broadcast FM, wide and narrow FM, AM, ADSB is in there as a default demodulator. So I like to use SDR Angel just because it's a very powerful tool. But if you don't like the UI or if you prefer something else, SDR Sharp is really good. SDR++ is really good as well. And then honorable mention to GNU Radio. I don't use this for a lot of my stuff, but it's a very cool software that if you're interested in SDRs, you can build your own radio essentially with drag and drop coding blocks that codes your radio in Python. So it's really fun to play around with, and it's really helped increase my understanding on SDRs themselves. SDR Angel is also available on Windows and Linux, and there's also an Android app as well for it, which is another reason I like to use that, because it's just compatible everywhere. OSs. So most of the programs that I talk about here are compatible with Windows XP and up officially. I've tested it on Windows 7, which is what my Toughbook is still using. I don't connect it to the internet, obviously, because that's a pretty dinosaur OS. And I'm going to be doing the demonstration today on Windows 10, and then it also works on Windows 11 that I've tried. So any one of the big Windows should be fine, and anything in between there, right, 8.1 or, like I say, down to XP should work just fine. The Steam Deck is running Ubuntu 22.04. I'd imagine it would work with most Ubuntu distributions, as long as you can install some of the basic software into that Ubuntu distribution, as well as Wine. And then I'd like to do an honorable mention to Dragon OS as well. Dragon OS is kind of what got me started with SDR. Dragon OS is a prepackaged Linux distribution that a fella made, and it has all the sorts of, this is for, right, Linux. It has all sorts of the libraries and software and everything that you might use to utilize your SDR, and there's a lot of cool stuff in there. It doesn't work for the ELT reads, unfortunately. I really wanted it to, but I could never get it to work, mainly because the compatibility layer, Wine, I was having some troubles installing it on Dragon OS, which is why I moved up to Ubuntu 22.04. And then for the ELT decoding, there's two that I know of that I use. The easiest plug-and-play one, and I think the cleanest one to start with and kind of integrate into your everyday operations, is called EPIRB Plotter. And that's from a guy, I believe, in Portugal. And very friendly guy. And it's a really good piece of software. We'll go into it a little bit later on. And then another one that I like to use, and that we'll download and I'll demonstrate a bit, is called MultiPSK. MultiPSK is a decoder for all sorts of different kinds of encoded radio waves. So it's not just for ELT, You can do ACARs in there. You can do ADSB in there. Those are the aviation ones. You can do all sorts of HF encode. You can do all sorts. I'll sort of show you some of the modes, but very, very powerful piece of software. Also uses the sound card to decode, and has a great wiki attached to it as well, where you can learn a lot about just radio in general, apart from just aviation radio. And then after we have everything installed and happy, we'll go into the operation. So let's start downloading. So the first piece of software we're going to download is the drivers for the RTL-SDR. So for these purposes, I've plugged in my NOOELEC V5 into my physical PC, and then I've also mounted that into my virtual PC as well. So that's mounted. So in order to get the drivers for that, like I mentioned, we're going to use Zadig or Zadig. I don't know how to say it really. Usually I just go to the RTL-SDR, just Google RTL-SDR install, and then there's going to be a quick start guide from RTL-SDR here, and it'll kind of run you through how to get it started. The first tutorial is if you're using your RTL-SDR with SDR Sharp. So SDR Sharp is just one of the SDR softwares that we briefly touched on a little bit ago. SDR Sharp comes packaged with RTL-SDR drivers already, but because, in my opinion, I prefer SDR Angel, I'm going to show you how to download just the drivers. And obviously, if you want to go back and get any other SDR software, they'll all work just fine after you install just the basic driver package. So if we scroll down to alternative software here, we see our little tutorial installing Zadig drivers. This is the web page you're going to go to. I'll link that with the video. And here's the Zadig website. So we're going to download that. Once we download, we'll go to it in our folder. Allow run. All right, now this is Zadig, the software itself. You don't have to install the software or anything. The software just comes as an executable in your downloads folder. And you're only going to run it once. So just get the drivers you need, and then you can get rid of the software if you choose. The official tutorial tells you to go to options and list all devices. And then you've got a few devices here. Choose the bulk-in interface 0. That's the one that it is for me. It might be different for you. The quick start guide on RTL-SDR has a bit more information. But we'll select our interface 0. Make sure this one's set to WinUSB, and then we should just be able to install driver. All right, once the driver is installed, we can hit close. We make sure that now interface 0 has that Windows driver or that Win driver in the actual driver slot rather than this slot over here, and we make sure this says reinstall. So now that we know the driver is installed, we can get rid of that. And the next piece of software we're going to grab, so that's going to be our Zadig. Obviously, that's going to be replaced by library files if you're doing this in Linux, but for our purposes, we'll just show it all in Windows. The next thing that we can grab is virtual audio cables. So same deal. You just Google virtual audio cables. I'll link this down below as well. And I usually use VB Audio. That tends to be the one that's the easiest, the most plug and play. And for your first set of in and out audio cables, it's free. So we like that. And here's our setup. We're on a 64-bit, so we'll run the 64. Hit install driver. And then once the install is completed, it'll pop up with its website there, little thank you page. You can just exit out of this. And it says installation complete and successful. So we'll do a quick restart on the PC, and we'll be back with you in just a sec. All right, now that our virtual PC has been restarted, we should be able to go down here to our speakers, and we're just going to confirm that we have our new set of virtual audio cables. So for output, we'll have a cable input and a cable in 16 channel. And then for our input, we should have a new cable output. The next piece of software we're going to grab is going to be our SDR software. I'll demonstrate with SDR Angel, but I mean, really, this is just like any other software. Pick the SDR software that is to your liking, and it should integrate more or less the same. So here's our SDR Angel webpage, free download. We'll grab this. It's just going to be a GitHub page, and we'll pick Windows 64.exe. Once we have that, we'll go through the setup. I'm just going through the default stuff here because this is just a virtual machine, but place it wherever you want, obviously. All right, and that should be that. And here's our SDR Angel. I'll just pin that to somewhere. There we go. That works. So now we can launch it up. This is going to be basically what you're greeted with right off the hop. So these are called configurations in SDR Angel. And I'll kind of, once you sort of see how the SDR Angel environment is laying out, the configurations will make more sense. So all I'm going to do right now is I'm just going to open the default configuration, which happens to be APT. And then we're going to kind of clean this up a little bit. So we can close down most of these pages. Or workspaces, I guess, as they call it. So as you can see here, it's picked up my RTL-SDR right away. But if it doesn't, you'll have this blank screen here. And then what you can do is you can hit this button up here, which is Add Receive Device. And then you have a drop-down menu. And your RTL-SDR should look something like this. It'll be a different serial number. You can rename those serial numbers. If you're only using one SDR, you can leave those default. So once you select your RTL-SDR and hit OK, it should load up the actual waterfall or the spectrum itself. And then over here it has the device. So we can combine these two pages so we can see it all on one page with this button up here. And now we have the actual spectrum that it'll be receiving, as well as the device control. See if we can make this a bit bigger. I don't know if I can. This is where you'll do your tuning for whatever frequencies you want to listen to. The other important things over here are also your gain. So RTL-SDRs come with an automatic gain control, which I typically turn on. And then if your signal is really weak, you can also manually adjust your gain down here. I never really use time delay. You can leave your samples per second at 1024. For our purposes, that's more than enough. And if you want, you can adjust your decimation rate down a little bit to 4 or 8. This should be fine. Either one should pick up a strong ELT signal, no problem. So you can just play around with these settings and see what you like more. We can leave the DC and the IQ correction as it is. Same with the local oscillator, PPM. We can leave that slider alone. What we can do now is we can tune to anything really. We'll tune to 406 in the nature of the video. And then when we hit play, it should start a data stream for the RTL-SDR, and that's what we have here. So obviously we don't have any antenna attached or anything right now. This spike is the DC offset. We can probably just ignore that. If you want to correct it, you can click the DC offset correction here, and you can get that spike to go away if it's causing you problems. But right now, here's what we're receiving. We don't have any sort of demodulation going on right now because we haven't selected a demodulator. To select a demodulator, you click this little Treyarch thing up here, and then you have your available channels. You have all sorts of goodies in here. The one we're going to use for ELT is going to be narrow FM, I believe. So, you know, we can choose any one of them, right? For instance, here's broadcast FM demodulator. We hit apply, and then you'll have another window pop up. And this other window gives you a few other controls, RF and AF bandwidth, volume, squelch. You can control all sorts of how you want your waterfall to look, right? This is all sort of visual stuff, how you want it to appear. RDS data, I'm not too sure what all this is about, to be honest. I haven't gone that in depth yet. But for right now, that's a quick run through on SDR Angel. We can close out of SDR Angel for now, and we'll keep getting the software that we need before we go any more in depth with that. So that's our SDR software. OS is covered. Next thing we're going to do is our ELT decoding software. So for this, I'm going to do EPIRB plotter first, and then as a little add-on after I demonstrate, we will do MultiPSK as well, in case you're interested. So we're going to go to EPIRB plotter. We'll go to the COAA page. I'll link this to you. This is actually his page. The nice thing about EPIRB plotter is it lets you use the software for a number of days before you register it. I think registration's about $30, something in that ballpark, and it lets you use it unlimited. And then once you buy it, once you have the key attached to your name, you can download it on multiple devices. So I have a key for EPIRB plotter, and MultiPSK is very much the same way in terms of keys, and I think it's even around the same price as well. So we'll go ahead into EPIRB plotter, same thing. I'm just going to do default installation because I don't really care where they all are, but you can place them wherever you want. Okay, and for the final part of this, this section, we'll launch up our software and make sure we can receive an ELT test signal. So the first thing I'd like to do is I just want to make sure my sound settings are set up correctly. As I mentioned before, you can set up like per application sound settings, but for my purposes, I'm just going to do overall PC sound settings because I don't need to use my speakers on this virtual machine or anything. So choose output device. I'm going to set that as my cable input, not the cable in 16 channel. You can ignore that one or disable it. So cable input will be VB audio for your output device. Choose your input device. We're going to set that as the cable output. So what we've done now is we've essentially tied the input and the output device through a cable so that anything that should be coming out of the sound card will go basically directly back in to the input. Now we're going to launch up SDR Angel. And I've already been in here to make sure everything works, but we'll start completely from scratch. When you launch it, it's going to come up with a little page. It says configurations. Just choose any one of those configurations and hit OK. And then this window here will likely be populated with a bunch of stuff. There'll be a bunch of tabs up the top, and there'll be a bunch of boxes in the tabs and everything. For your purposes, you can just close all those out. So let's just do a demonstration of that. This is going to be the configuration page that you come up on when you first launch SDR Angel, and it'll ask you to choose a configuration. Just choose any one of them. We can choose ADS-B. And then this is what you're actually going to be greeted with here, right? Is you've got a bunch of tabs up at the top, and you've got a bunch of windows and stuff like that. We're not too worried about any of this right now. So we can close out of any tabs you're able to close out of. Obviously, there's some that you can't really close out of. But we'll close out of as many as we can, and hopefully you'll be able to get to just a gray screen. And then the next stop is going to be setting up the device in SDR Angel and the output in SDR Angel. And the demodulation as well. So the first step is we're going to add a new received device with this button up here. And then assuming all the driver download and everything went well, you should see your RTL-SDR in the list somewhere with a serial number attached to it. So we can select that. We'll hit OK. Quick note on the software. If for some reason you don't see your device, in this case, we don't see my device because it's already selected. But if you don't see your device, unplug the RTL-SDR, plug it back in, and then hit your refresh. And it'll kind of reset to see if it can see anything else in the list. Once we select it, we'll have two tabs up at the top, RTL-SDR device and RTL-SDR spectrum. We can combine those two with this button here. So we have our device control block here and our spectrum block here. So we can tune this to 406. And just a quick note on ELTs. Every ELT will have its own output frequency. They're not all on exactly 406 megahertz. They kind of vary between 406.025, some are 406.040, some are kind of in between that. The ones that I've recorded so far majority of them are 406.040. I think I have an older French ELT that is 406.025, but for the most part, 406.040. That'll be on the data plate of the ELT or in the install manual of the ELT as well. Decimation, we're going to leave that at 16. All this we can pretty much leave alone. We can turn on the DC correction. You'll see why in a second. Bias T, leave that unselected. We can leave this to center. We can leave our sample rate to 1,024,000 samples per second. That's more than enough for our purposes. All this we can leave alone. This is going to be one of the main important things right here is your gain. The RTL-SDRs have an automatic gain control checkbox that I like to keep checked. It basically just ups the gain a little bit when you're not sniffing anything. And then if you get a signal that's clipping or that's way too high for the RTL-SDR to receive, it'll sort of tune down its own gain. And then we can also play with gain control here as well, independently of the automatic gain control, for if you're really trying to pick up a weak signal. We'll be playing with that quite a bit. Once we have kind of the basis set up, we can hit this play button up here. And then we should start to see our spectrum. So here's all the kind of noise we're receiving between sort of 406.008 megahertz and 406.072. That's kind of the band, the default band we're picking up here. We'll change the actual band it's listening to in the next step. But for now, we want to make sure that, yeah, the device is working and we're seeing some stuff. Here's what that DC offset does. If we turn this off, we'll get a spike right in the middle of our tuning band. I don't really think it does a whole lot, but it's kind of an eyesore, and it makes the spectrum make more sense if you turn on the DC correction and you just get a nice flat spectrum on your waterfall there. So the next thing we want to do, first of all, we can probably make this a bit smaller. There we go. The next thing we want to do is what's called add a demodulation. So up here, right beside the name, there's a little Treyarch thing. Add channels. And then here's your available channels. And there's a ton of different types of channels you have available, all sorts of different fun stuff you can use. The one that we're going to use for ELTs is narrow FM. So ELTs use an FM transmission. They use pulse shift keying. And that's going to be picked up by narrow FM demodulator. So we'll select our narrow FM demodulator channel. We hit apply, and then we got a new box. Close this down. This new box, we don't really need to do a lot here. What we will do is we'll turn off our high pass audio filter. And typically speaking, because we're routing it through a virtual audio cable, I like to totally get the squelch to minus 100. So there's no squelch gate at all. I like to disable the squelch gate so that everything that the RTL-SDR is picking up is being routed through that audio cable. Because at the end of the day, it's just getting picked up by additional software anyway. So it's not that important if we hear noise. So now that that's all set up, we can put this program aside for a sec, and we can launch up EP-IRB plotter. This is what we're greeted with the first time we launch. Basically, it's saying it gives you a 21-day free trial period, and every day you use the software, it'll kind of start counting down, or counting up, I guess. It's a nice little grace period where you can make sure everything is set up and everything works. And then when you're ready to register, just hit yes, follow the steps. And I think it's, like I said, I think it's like $30 or something through PayPal. And he registers your name on his servers. And then whenever you download the software on a new device, you're able to transfer your key. So it's a really nice little program, especially if you want to have this installed on multiple devices. So we'll hit no, we don't want to register right now. And here's EP-IRB plotter. So there's a few basic options up here. One of the first things we're going to check, we'll go to options, we'll go to audio, we go to source, and you can set that either to automatic or to cable output. We'll leave it set to automatic because that's the default, and we'll make sure that it works picking it up on auto. There's a few other options here. There's the three different types of graphs you can check. I usually go to the wave graph, the signal graph, first of all, when I first start picking up signals or when I first start scanning for signals, because you'll sort of see some noise figures here and some waves. And that's how you know that EP-IRB plotter is listening to the right devices, to the right sound device, to the right software, things like that. So we can leave that on our signal, on our little wave graph here for now. And we can hit record. That's what this little green button up here is, or start. So now that we've hit start, it should theoretically be listening to whatever audio device it's picking up as outputting. You can see some of the noise here. This is just going to be noise from the sound card. So we go back to our RTL-SDR. We have everything set up, or we should. We're going to hit play, and we'll start to see a waterfall happening here. We can adjust the gain up a little bit. We'll see if we can get some stuff green. And now we go back to EP-IRB plotter, and you'll see a bunch of waveforms happening here. You can see we have some clipping at the bottom there, so maybe we tune our gain down a little bit. This is something you can kind of play around with as you're picking up signals. But now we know that SDR Angel is talking to our RTL-SDR, and then our virtual audio cables are working, and then it's funneling information to EP-IRB plotter. So your next step is going to be go to the message selection on EP-IRB plotter, and we should now theoretically be sniffing for ELTs. Okay, so now what we'll do is we've got all of our software hooked up and we're ready to listen for ELT signals. So I've I've recorded some live ELT transmissions using my Hack RF while I was doing ELT tests on live aircraft. And I'm able to replay those with the Hack RF into a direct couple for the RTL-SDR. The reason I've done this is basically for testing, so I didn't need to constantly be at a live aircraft or constantly be setting off ELTs to troubleshoot and to try and get this up and running. So I will go into my Hack RF here, and I will select my file. And then once I hit play, make this a bit bigger here. Once I hit play, we should start to see this waterfall populate with some signals. And there we go. There's one right at 406040, and that's the pulse right there. And then as you see, we can hit, oh, we'll leave this running actually. It populated EPIRB plotter with our ELT information. So that was just one burst. That's the test signal from one of the ELTs, replayed into the RTL-SDR, and it immediately picked it up. So it has your EPIRB test detected at date and time in UTC. It has the UIN, so the identifier number for the ELT itself, which is typically what you're checking when you're doing an ELT test. Some other stuff, format protocol. It has the country code, the user code. It also has the, the COSPAS approval number, the serial number, as well as the GPS location. If you were to integrate your ELT with a GPS position, either like an AirInc from your aircraft GPS, or even like a standalone GPS specifically for the ELT itself, your ELT location will come up here as well. And that's really all there is to it. We should be able to just pick up as many ELTs as possible. The only caveat is sometimes, depending on the ELT manufacturer, there's going to be a different range that it outputs on. So you'll be able to see that in your waterfall, but because this is our narrow FM, this is what we're picking up, what we're specifically listening to the RTL-SDR, it might not pick it up as good. Some ELTs transmit over here kind of between like 406.025 and 028, so kind of in this range. So if you're replaying your ELT signal, or if you're testing your ELT and you're just not getting any population, what you can do is you can just tune this over to here, right? Kind of capturing those lower frequencies, and you can try to pick it up doing that, right? So you do have tuning control here as well. Apart from just the spectrum you can see, you can narrow it in. And this is what it's actually outputting to your speakers, is just the stuff in the red band. So one other piece of software I'd like to show before we close out is called MultiPSK. MultiPSK is the software that I started out reading ELTs with, but for some reason I was having consistent issues with getting the identification number to populate on MultiPSK, which is basically the only reason we read ELTs. So I decided to look for alternative softwares. I'm not sure if it's related to the fact that we're doing an ELT test rather than a live ELT set off, but regardless, I wanted to talk about this software because it's really powerful, and it's really good to know about, even if you don't use it. It really helped me a lot in the beginning. So this is the MultiPSK website, and we're going to download it in English. So we'll download the latest version of MultiPSK. Okay, we don't need to do that. We're going to keep anyway. Go through the install. And it should have given us a couple of desktop icons, which it did. So it comes with 3 programs. It comes with MultiPSK, OM Map, and Clock. I've never really played with OM Map or Clock. I mostly just use MultiPSK. So we'll launch that up. Here we have our configuration screen for MultiPSK. I won't go super in depth again into the software, but it's just good to know it exists, and I want to get some more leverage on it for the developer, because it really is incredible. Now, the cool thing about MultiPSK, and I touched on this right at the beginning of the video when I was talking about hardware, is MultiPSK can automatically integrate with RTL SDRs. So without SDR Angel running, without really any other piece of software going, you can click the RTL key, DLL, and it'll automatically detect the receiver via the RTL DLL. And it can integrate directly with that for decoding purposes. So you don't have to channel anything with virtual audio cables. You don't have to look at the waveforms with SDR Angel, none of that. It automatically picks it up. So tons of options up here you can play with. Basically sound card inputs. This is what's obviously what MultiPSK uses for decoding, just like EPIRB plotter. Sound card output, sound card auxiliary, right? If you want to be listening to whatever you're decoding, you can have it set to the auxiliary. Tons of different things. Way too much to go over here. But if we go to our receive transmit screen, then you can see there's tons of little goodies all over the place here. Here's our IQ Direct. Here's how we would control our RTL-SDR with all sorts of different modulations. We can do AM, upper sideband, lower sideband, different FM bandwidths you can select, all sorts of stuff. And then here's all the modes you can choose from. So I was primarily using EPIRB mode, which is for ELT, distress beacons and things like that. It also has VDL2, which is basically like a replacement for ACARS kind of. It does also have ACARS up here. You can listen to ACARS frequencies and it'll decode in this big white box right here. All sorts of cool little decoding things. Tons and tons and tons of different modes that this guy has built into his program. And what's even better, almost worth downloading the program just for this, is if you right click on any of these modes, it'll bring up a wiki, and then the wiki gives a bunch of information. So here's EPIRB, which is like ELT. Here's all about that mode. It tells you all sorts of different stuff, information about the mode, information about how it's encoded, information on how to decode it, how the systems work. Yeah, very good stuff. Very cool to know. This was a huge help when I was trying to get my reception to work. And it has that really for every other mode that you can pick up. ACARS, it has ADSB, tells you all about ADSB. Very cool stuff. Not necessary if you just want to read ELTs, but it's good to know that it exists. So we'll close all this down. We'll go back to our desktop, and that's pretty much how to read an ELT with software, plus a little bit extra, a lot extra, really. It's definitely felt like a bit of a rambling video for me, but it is something I'm very passionate about, and I hope it comes in handy. I hope you're able to get it up and running on your Windows PC, and maybe it makes some ELT reads easier in the future, and maybe even gets you interested in SDRs and looking at what other things SDRs might be able to do, checking out the ADSB modes on SDR Angel, or even going into MultiPSK and trying out different decoders, demodulators in that software. But tons and tons and tons of stuff you can do, and definitely some limits that I haven't found yet. So hopefully you enjoyed the video. Hopefully you didn't have any problems following along. And if you did, just mention it, and we can try and figure it out together. And yeah, that's about it, I think. I hope you have a good day, and I hope you are able to read some ELTs in your future.